This video is about absolute value solution sets. So we want to know what these solutions look like when we're dealing with absolute value. As you'll recall, absolute value is the distance from zero. So if we had the absolute value of 10, then the absolute value of 10 is 10 because it's 10 spaces from 0. If we had the absolute value of negative 10, then negative 10, the absolute value of negative 10 would also be 10 because it's 10 spaces from 0. So notice there are two numbers, distinct numbers, 10 and negative 10, that give us the same result when we take the absolute value. So when we think about it backwards, if there were an x in the absolute value, we have no way of knowing whether it was the positive or negative number. And so we have to account for that in our solutions. So let's look at some examples. The first one says, which graph is the solution to absolute value of x greater than 10? And so again, how do we account for that? So we know that x could be 10, so we have x is greater than 10, or we could have that x was the negative 10, but when we're dealing with the inequality, that means the sign will change if we change the sign of the value. So how do I graph this? Well, we're going to put it on a number line. And here is negative 10, and here is positive 10. When we have an inequality and it's not equal to, we have an open circle. So both of them are going to have an open circle. And now let's take a look at the rest. So greater than 10, so greater than. So we're at 10, we want greater, so greater is to the right, towards the bigger numbers. So it's all of these numbers. And on the other one, we want less than negative 10. So less than means smaller, goes towards smaller numbers. So we're going to go to the left of negative 10. And so altogether, that entire number line is what the graph would look like for this solution. Next example, solve absolute value of 2x minus 5 equal to 4. So again, we have to take into account that there's going to be two possibilities. So we solve this as 2x minus 5 equals 4. We also solve this as 2x minus 5 equals negative 4. Because again, we want to know that inside that parentheses, all of that squished together could have been the positive or the negative value. All right, so let's solve. So we solve it just how we would work with any other equation by solving for x. So we're going to add 5 to both sides. And so we have 2x, that's 0, equals 9. Divide by 2. 9 halves, or 4.5, is our first answer. Same thing over here, we're going to add 5 to both sides. We get 2x, that's 0, but negative 4 plus 5 is 1. Divide by 2, x is 1/2, or 0.5. 0.5. So what is our solution? So they tend to write this in what we call set builder notation. So we have a curly bracket, and we say x because that's a variable. We're telling our reader we're using x as our variable. And then we say x equals 0.5 or x equals 4.5. And we end our curly bracket. And there's our solution. Last example. Absolute value of x equals negative 2, and they ask us to graph the solution. Okay. So, in looking at this, we have to think, if I take the absolute value, can I get a negative value? And the answer is no, because of the definition. The definition says it's distance from 0, and distance cannot be negative. Even though we can go in a negative direction, that doesn't mean that the distance itself is negative. So in this case, when we look at this, absolute value cannot equal a negative number, so this would be no solution. There would be no way to actually graph this. That's it for this video. As you go through the lesson, if you have questions, be sure to ask your teacher. Have a great day.